Now let's look at a couple of non-parametric tests where the number of groups being compared is 3 or more. The KruskalWallis test uses ranks of data from 3 or more independent simple random samples. Its parametric equivalent is the one-way ANOVA. The null statement is that the population medians are the same for 3 or more independent samples. The alternative statement is that the population medians are not all equal for 3 or more independent samples. The assumptions for this test are a simple random sample, and each of the samples must have 5 or more values. This test is particularly useful when grouped samples strongly deviate from normal and sample sizes are small, unequal, and non-symmetrical. The test is also robust when there are differences in group variances due to the presence of outliers. The test statistic is shown here and is based on the sum ranks of each sample, R sub k, number of observations of each sample, N sub k, and the total number of samples. Note that H is distributed similar to the chi-squared distribution, with k-1 degrees of freedom. A critical statistic based on the chi-square with alpha and k-1 degrees of freedom will be generated to facilitate our decision. Let's look at an extension of the last example. Suppose we add a second treatment. We wish to see if there is a difference between the medians of these groups. Assume alpha is 0.05. Since there are 3 groups, this will be a degrees of freedom of 2. Using technology, the test statistic is 15.043. This gives a p-value of 0.00054. Since the p-value is smaller than 0.05, we reject the null. There is a difference in the medians. The Friedman test is a non-parametric test that uses ranks to compare the paired differences of the medians of 3 or more groups. Its parametric equivalent is the repeated measures ANOVA. The assumptions for this test are a simple random sample. Also, there should be no interaction between the rows or treatment levels. The null statement is that the median treatment effects of the population are all the same. The alternative statement is that there is a difference in the median treatment effects. The test statistic is given by the equation shown here. R sub j is the sum of the ranks for sample j. N is the number of rows of data. K is the number of treatment levels. Note that Q is distributed similar to the chi-square distribution, with k-1 degrees of freedom. A critical statistic based on chi-square with alpha and k-1 degrees of freedom will be generated to facilitate our decision. Let's consider this example. Suppose we have 3 cola brands, Fizz, Diet Fizz, and Fizz Zero. We ask each person to sample each drink and rate on a scale from 1 to 10. Is there any difference in the medians of the 3 colas? Assume alpha is 0.05. Since there are 3 groups, the degrees of freedom will be 2. The test statistic is calculated using technology and equals 2.0417. With 2 degrees of freedom, this gives us a p-value of 0.36029. Since the p-value is bigger than 0.05, we will fail to reject the null. There is no difference in the median of the 3 colas.